Alright, this is my brushless motor project created by me, Beth. This is a picture of my motor. It has a stator poles, rotor, magnets, and magnet wire. I designed and 3D printed the stator and the rotor. The stator is 3.5 inches wide with 12 poles prepared for the stator poles, and the rotor is 1.5 inches with 4 holes prepared for the magnets. And as you can see, it's indented, so they'll be able to rest inside the rotor and make the motor a tighter fit all around. The magnets, so as you can see, the stator poles are able to be a closer fit along the rotor without actually touching the rotor. So the magnets will rest with their positive, opposite of each other, as well as the negatives. And just like it is shown in this picture. And now we've come to the stator wiring. So the stator poles are made with 3-inch screws with 832 threading. And the wiring is very important, I've come to realize, as we create the coils for the motor. So there are 3 individual bundles of wiring with 6 separate strands in each bundle. And the wire is 26 gauge AWG magnet wire, and they're cut into 15 feet long length. I didn't end up using all 15 feet, but for all intents and purposes, that's what I cut it into. So the wiring is labeled A, B, and C. As you can see, there's the blue is A, the green is B, and the red is C. So we'll start. So following the diagram in its exactness, like I said earlier, is a very important part of the motor in order to make the motor work, really. So we're going to start with A+, and we're going to wrap the wiring around clockwise around A+, and then go to A+, and then go to A- and wrap it around, and then just do the same for the next two. So it's very important that the positive is clockwise and the negatives are counterclockwise, and this is the same for B and C. So we started A+ over here, and we'll start A C+ over here as well, and just go all the way around with the clockwise and counterclockwise, very important. And then with the B+, instead of starting up here, we're actually going to start on the opposite side and go the opposite direction. So B+ to B- to B+, and then to B-. And then B- goes up to where the wires will be inputs, as well as the C+ and the A+. And those will be connected into the ESC a little later, while the B+, the C-, and the A- will be linked together. And how I did that, I just soldered them all together. So I soldered these 3 bundles together, and then I just soldered each bundle together separately. So I just A+ I soldered together all the 6 strands. Same with C+ and B-. Right? And it's very important that the B+ starts down here in order for the motor to work. So now the stator poles, they do need to have 24 windings. That's just all together. That's the number I chose to be able to make my motor work. But once I choose a number, I had to stick to it. So that's why I ended up not using the whole 15 feet of wire in the bundles. But I made sure that every single stator pole had 24 windings, and counterclockwise and clockwise with the positive and negatives. So now, once they're all wrapped up, like I mentioned earlier, the A+, B-, C+ wires are going to be inputs, while the A+, B+, C+, or C- wires are going to be linked together. So now we're going to go on to the Arduino and the ESC hookup. So like I said earlier, again, gonna repeat myself, but the A plus, B minus, and the C plus wires will be connected to the ESC here, and any of the hookups will work. And then the ESC will be connected to the Arduino right here, where there's control, power, and ground. Control will be connected to pin 8, ground will be connected to ground, and power will be connected to 3.3 volts. And then the potentiometer on the breadboard is connected to a 0, and then 5 volts and ground. Now the ESC can be connected to the battery once the code has been updated and the motor is all ready to go. And the motor will power right up, so it'd be awesome. And then just another close-up of the Arduino, just another look. And now we're on to the discussion questions. So, how many turns per minute did my motor spin? So we estimated about 2,000 per minute once the motor was at its highest motive power. And how many turns did you have on the motor's windings? I had 24 windings with a bundle of 6 wire strands. What happens if the number of turns on your motor were increased or decreased? If the number of turns were increased, the motor would spin with more power and faster because it would create a larger electromagnetic field. But if the number of turns were decreased, the opposite would occur with slower spins and less power because of the minimized electromagnetic field. How could I have made my motor more efficient? So to make the motor more efficient, I could have replaced the regular kitchen magnets that I used with much stronger ones that could have handled the power of the electromagnetic force that was being exerted, as well as the handling the weight of the propeller much better, because it did go faster, more smoothly when the propeller wasn't on it. But once I put the propeller on it, it was a little bit harder to get up to speed. We were able to do it, but it was just a little bit harder. So I could have also added more stator poles with the equivalent amount of added magnets to create an even larger electromagnetic field and a stronger motor. What was the input voltage of the motor? And that was around 12 volts. What type and how many magnets did you use for your motor? So, like I mentioned earlier, I just used the round metal disc magnets that are primarily nicknamed kitchen magnets. I used 4 of these types of magnets in the rotor. So what gauge of wire did I use for my motor? The wire gauge is 26 AWG and is one of the single strands of wire. So, and there's 6 strands in a single bundle. So 26 would be multiplied by 6, which would amount to 126 gauge wire. So what do I think the relationship between wire gauge for windings and the motor efficiency is? So the more strands in a bundle of wire with more coils can produce more of an electromagnetic field, which obviously creates a larger electromagnetic field. But too many strands can be too much for the motor, so there has to be a balance between the two. Does your motor generate any heat? And if so, why? So the motor did generate heat, and it's because the amperage causes heat to occur. So what is the resistance value of the windings in your motor? And that would be around 350 ohms in the windings. And what is the amperage draw of your motor? The amperage draw was 8.6 amps. When you immerse a current carrying coil in a magnetic field, is there a net force on the coil? And no, there is no net force exerted. And that is the end of my slideshow. Thank you and have a great day.